Hey everybody, this is Mr. Munson, and we are starting Unit 6, Similar Polygons. And so this video is going to cover some of our basic vocabulary words. We have it at the beginning so that you have the unit to kind of learn and understand these vocabulary words. Vocabulary is the key. If you haven't gotten that yet, you need to make sure that understanding the vocabulary words and using the tools that I give you to understand them allows you to do better on tests and quizzes and to understand concepts. All right, let's get started. Okay, let's go ahead and get started. And we're looking at the first word, ratio. Okay, so a ratio is a relationship between two things. Again, we're looking at numbers, of course. Two different ways of writing ratios. We'll look at that in a second. Both have their benefits. So suppose I was looking at this example. There are 13 boys and 14 girls in our class. Write a ratio between boys and girls. Now I'm going to quickly just write over here kind of the order, if you will, boys, girls, okay? So I could write as a ratio of 13 boys to 14 girls. Now another way of writing the ratio is boys to girls, like that. And so we'd write the number 13 colon 14. Now they both represent this ratio, so we'll have benefits to both of writing them in these different ways. Remember, we're always reducing these items. Seeing it as a fraction makes it a little bit more easier for you to kind of remember to reduce, but we still reduce it when it's in this form as well. Next up is a proportion. A proportion is basically an equality relationship between two ratios. Now we've been writing proportions for a while now. I've kind of forced them on you, kind of brought them in the back door. And so here we are formally introducing them. Hopefully you know how to solve a proportion like that. You'd cross multiply. Hey, I always like to remind people, students, to put parentheses around quantities like that. So when you cross multiply, it makes sense. Now we're not going to take the time to solve it here, but we just remember to take something like this and distribute it across through that parentheses, okay? Now this is just a series of 12 times 2 times x, 24x, right? 24x, and then over here we'd get 12x minus 4. And we just keep on processing it here. This is a process we know as cross multiplication, right? Which brings us to our next thing, cross multiplication. Again, cross multiplication is just a process used to solve proportions. Whether it's cross multiply across an equation, just keep in mind when we cross multiply, we're rewriting the equation. That means the thing that we write over here will have an equal sign, right? So there it is. I've went ahead and distributed the 4 across the 5x and the minus 1 to get me 20x minus 4, and we just continue to process this. A lot of times at this stage of the game, I'll have students forgetting to bring in that equal sign. We start with an equal sign, we'll end with an equal sign. Similar polygons are polygons that have corresponding angles that are congruent and sides that are proportional, meaning this, okay? So if I looked at an angle in here and an angle in here, they should match up and be exactly the same measure, okay? Same thing is true for the other corresponding angles. So if you take a look at K, it corresponds to N. So I know that if these triangles are similar, then angle K and angle N are congruent. Now the sides are not congruent. They're proportional, right? The whole idea is that one is larger than the other. And so when we write a ratio between any two corresponding sides, that ratio, that fraction, will be exactly the same fraction as if we grab two other corresponding sides. When we do that, we can come up with what is called as the scale factor, and again we'll go through this in a little bit more detail, but the scale factor is basically telling you how much bigger or how much smaller your item has gotten, your polygon has gotten. Now take a look at this symbol here. It's basically a wavy symbol like that, and as I'm stating here, notice the symbol for similarity above, okay? It's the top half of what? The congruent symbol, okay? These shapes are not equal. Their sides are not going to be equal, but they're going to be proportional. So that little symbol stands for similar. That means, both shapes are triangles, both shapes are hexagons, whatever it is that we're looking at. Similarity statement is a statement showing that the relationship between two corresponding parts of triangles or of similar polygons there's the relationship is that for the angles are congruent and the sides are proportional. So when we write this, it's very similar, if you will, to the statement that we did last chapter where we were looking at congruent triangles, okay, or in chapter 4, I believe it was. So we have order mattering, right? Now in my class, whoops, I'm sorry. In my class, we're going to always be writing the first triangle or polygon in alphabetical order, okay? So J, K, L, and then the next one, in this case, is in alphabetical order, but it might not. But this is what I do know. I do know that angle J and angle M are congruent. Side JK and side MN is just two sides, right? The ratio between them will equal a ratio between any other two sets of sides. Again, we'll go into that in a little bit more detail as we go through this unit. Keep these vocabulary words handy so as we're walking through that, you get it. All right, so scale factor is the ratio. Remember that means ratio, fraction. So as soon as you hear that ratio, think a fraction. The scale factor is the ratio, the corresponding linear measurements. So it's the side lengths of two similar figures. Okay, so if you find two sides, one side in one figure and the corresponding side in the other, and you write a ratio between them, that's the scale factor. The scale factor is the same no matter which pair you grab. That's what this big statement that has actually two equation symbols in it, right? It means that if I grab two corresponding sides, one from one triangle, one from another, that fraction will be equal to the other corresponding pieces. So now, to prove triangles or polygons are similar, you have to show that for every angle in one of the figures has a matching congruent angle in the other figure. And then you have to grab a side from the first figure and the corresponding side from the other and make sure that that ratio, that fraction between those two sides is exactly the same as the ratio of all the other corresponding sides. Now, if you're looking at a hexagon, that could take you a while. Looking at triangles, it still can take you a bit. But what we find is, like in the world of congruence, there's some shortcuts. So it's enough. If I have two triangles and I have just enough information, I can tell you that the figures are similar. So here's the two shortcuts. I want you to put me on pause and see if you can go through this page and see if you can come up with what you think is the theorems. Now, this is where you'll stop. So see if you can come up and fill in the top part of that on your own. Put me on pause, come back and check your work. Well, the first one here is the angle postulate. It's AA and then the similarity statement after it. And basically it says if I have two triangles, if I see that there's two angles in one triangle that matches two angles in the second triangle, then these two figures are similar. And once I know they're similar, then I know the third angle, in this case T and P, are congruent. I know that the sides, I can write ratios between the sides that will all be the same. I can come up with a scale factor and so on. And again, we'll learn a little bit more about that as we progress through the unit. Side angle side says basically that if I have two sets of sides, so if you look over here at this proportion, if I know AB corresponds to QR, if I write a ratio between those two pieces, and then I write another ratio between AC and QS, if those two ratios are exactly the same and the angle trapped between them is the same, then we have two figures that are similar. Okay, and that works for triangles. Now remember, the sides, when you write this ratio, that's what's going to be the same, not the sides themselves. Remember, the shapes are different sizes. Side, side, side. Basically, the ratios between corresponding sides all have to be the same ratios. They all have to reduce down to the same number and be the same, right? So we have side, side, side similarity. We have side angle, side similarity, and angle, angle similarity. Let me go ahead and write in the shortcut abbreviation, side, angle, side. You'll always have to put the similarity in there, otherwise it's assume the shortcut for congruence, okay? And then we have side, 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 similarity. All right. Side, this is called the side splitter theorem. I kind of enjoy this theorem. It basically says that when I have these lines that are parallel, right? What that does is it kind of busts up these pieces into being in such a way that I can write a relationship between them, a proportion between them. So carefully take a look at this proportion and relate it to the sides and see how it's written. Okay? Just want to point out a special symbol that you're going to see me writing more and more. It's this symbol right here. And it basically stands for the word then. Okay, so I don't have to write the word then. I can just write that symbol. It's kind of an equal sign with an arrow on the end, right? So if you come down here, that's what should be in that spot. Okay, folks, that's it. That's your vocabulary words. We're going to start this unit next class. All right, take care.